Welcome to Open Networking TV. This is the Catch Up. I'm your host, Art Fuel, and today we will be catching up with Peter Phaal, the president and the co-founder of InMon, who you may know of as the founder, the builder, creator of sFlow technology. And as things proceed into SDN and next generation technologies, you guys have continuing to, I think, really deliver on key innovations. But let me, if you wouldn't mind, Peter, if you could introduce yourself, give us a little bit about your background.
Yeah, hi. It's good talking to you, Art. I have a sort of long history in the network management space. My first job was at HP Labs in Bristol, nearly 25 years ago. And measurement has always been a sort of a passion of mine. So the sFlow standard, is really, its DNA is in HP's roots as a measurement company. And really it's kind of grown with the commoditization of networking. It's built into merchant silicon, and as all the vendors move to merchant silicon-based platforms, that's really driven the growth of sFlow in the market. And I think the really exciting thing more recently is the emergence of SDN. Because in the past, network management has been kind of boring. It's something that most vendors have kind of given away with their products. They don't value software. But analytics, I think, are really the key to making SDN useful. Because if you think about it, if you can control switches and provision them dynamically, that's only half of the solution. What you want are measurements to create a feedback loop in which you can then decide what the best thing to do is. And that's where I see the sort of next generation of SDN really emerging and delivering value, is in creating self-aware, self-optimizing software-defined data centers. And I think sFlow is going to play a pivotal role in that, in providing the analytics plane to complement the configuration and control planes that are currently what most people think of as SDN.
Outside of those areas where you've got an SLA, we haven't always, enterprises in particular, haven't always invested as heavily perhaps as we could. And I think a lot of that has been, there's been a lot of really complexity in management software. We've seen, you need to have 32 different packages to really be able to deliver on all the functionality you want to deliver on, and then you had to somehow string them all together, and it's become quite messy. And I think SDN may be one of the areas that helps to clean a lot of that up and help us to have a more powerful and consolidated tool set. I'm curious about your thoughts on that.
Yeah, I agree. But SDN and sort of like OpenFlow don't really do a good job on the measurement side. And really that was the goal that we had, is when we started InMon, most of our competitors were looking at the space and saying, okay, I'm going to have to deal with whatever vendor proprietary SNMP MIBs are out there and whatever APIs they choose to expose. And we looked at that and said, well, there's only so much you can do with that. If you really want to do a great job with network management, you really need to have a common set of core measurements that are built into every switch. And so we had the sort of rather quixotic goal of embedding our measurement technology into the hardware. And that's really what took 15 years, is getting the instrumentation ubiquitously implemented in networking hardware. And today that's really happened. Pretty much every switch you buy has the measurements built in. So I agree, the complexity of adding measurement on is really challenging, adding probes to switches. And you look at large scale data centers with hundreds of top of rack switches and spine switches, there's really no place to add taps and put probes. You really need measurements that are just built into the hardware infrastructure and deployed as you deploy your network. And then, so we see it as sort of a base functionality that's just part of the hardware. And then you just turn it on and you have the visibility with none of that complexity, because it's it's not an add-on. It's not something you need to configure.
It's just there. There's a lot of stuff happening in the industry this year, and I'm curious for you, what are some of the let's start with this one of the things that you're fascinated by that's happening this year, or what might happen this year.
The kind of topics that interest me are clearly sort of based on our experiences. As a software vendor, working in the networking space. And so really, I think an architectural change that's fascinating is network virtualization and how it's really transforming networking. And we work closely with the Open vSwitch project. We implemented sFlow there, and really what we see is all the sort of complex functions that used to reside in your core chassis switches is moving out into the software edge, into the virtual switches, and into virtual machines running on the hypervisors as network function virtualization takes hold. And that dramatically simplifies and commoditizes the features that you want out of your network hardware. And so I think people are then moving to fixed form switches and leaf and spine architectures to get the large amount of internal bandwidth you want within the data center to carry storage, do VM migration, and so on, is really disrupting the market. You have this rapid growth of network virtualization and the simplification and commoditization of the physical hardware. And so I think that's a really interesting trend.
And as this network virtualization has taken hold, there's been a lot of interest in if I have an overlay and I have my underlay, there's angst and there's concern if from network engineering community, if we implement this and our necks are on the line, and someone says they have a application problem between VMA and VMB, where do those VMs physically sit? What physical pathway? And then on top of it, having to troubleshoot in the virtual layer. Would you mind expanding more? Like, what innovations are happening there that's going to make this new complex stuff more manageable for people?
Well, you're right. There is a certain degree of complexity to it, but there's also a simplification that you get from network virtualization. In that, one of the reasons you do it is that it provides a very dynamic and flexible edge. You can stand up VMs anywhere, and you can create virtual networks that represent complex policies that are hard to realize in sort of fixed hardware ACLs and switches.
And I think to that point too, like right there, another one that stands out as a real obvious benefit is you want to be able to define your application container and your policies associated with that application in one place. And just picking one example, if you're a VMware customer, you do that in vCenter, right? Or whatever the newest one is. They've changed the acronym a few times just recently, and that seems to be, and it makes it. The framework is already there to say I'm going to define my policy in the self-service environment. It's going to automatically move with the workload, where whatever virtual switch it happens to attach itself to is going to be able to enforce that policy. I don't have to worry about creating some type of policy distribution mechanism to send that same policy to the to the network edge, the physical network edge. And it seems with workload mobility, like that's probably a good thing.
But also software is just a lot more flexible. So there's always fixed capabilities in a hardware platform, whereas software life cycles are just much faster, and innovation happens much more rapidly. So I was at the Open vSwitch conference, and they were talking about all the performance enhancements they've made to Open vSwitch and being able to add stateful firewalls to the vSwitch, and leveraging the infrastructure in the Linux kernel, and Intel was talking about how they're accelerating Open vSwitch. And so I think the pace of innovation that you can expect to see at the edge is going to just rapidly exceed what would be possible in hardware.
I think Open vSwitch is such a great example of that, right? Because pick a topic, from programmatic networking to OpenFlow to monitoring to if you're somebody who's in development or trying to innovate in Ethernet switching technology, you're probably doing it on Open vSwitch because you have the flexibility there to do things not only that a lot of OS vendors may not allow, but even beyond that, where the hardware may not optimally support what you're trying to do yet, right?
Yeah, and most of the vendors that are delivering network virtualization are using Open vSwitch to do it. They might not be using the standard management plane, but they're certainly using Open vSwitch kernel module, and thinking of VMware with NSX or Medicura or Nuage, they're all using Open vSwitch to do the network virtualization on the hypervisors. And what's really interesting is, I don't know whether you were following the Open Virtual Network project that Open vSwitch just recently started. And I think that's going to be really exciting to sort of up the level so that you have a really robust network virtualization component that integrates with OpenStack. I think it'll really accelerate the adoption of virtual networking.
Now, you also mentioned, we're seeing a lot of advancements in open architectures from, spine leaf is almost a given because you see it like, it just seems to be pervasive, and it's being built into, what's becoming kind of like the new almost x86 of networking, where we're seeing standards-based networking platforms kind of led most notably by the Open Compute project. And it's starting to change the face of networking. Now you look across a lot of different vendors, and depending on which platforms you're looking at, you're starting to see this almost server-like model emerge in networking. I'm curious, what do you think? How do you think that's going to impact, or what interests you about that segment?
Well, I think following on from our conversation about network virtualization, I think that's one of the things that's driving the commoditization of the hardware. I mean, if you look at a top-of-rack switch from pretty much any vendor, it's likely a Broadcom Trident 2 chip inside, and really identical hardware. And the feature set that you need is really just an efficient way to bring up ECMP forwarding. And so it's a very limited feature set that you need to build these networks. And so I think that's really what's driving the move to white box, because as you unbundle software, hardware, you have these hardware platforms that are do the job, and then you have control planes that you want to add on there that fit into whatever orchestration system you want to deploy, so you can reduce the operational cost of managing switches. I think pretty soon CLIs will be dead. You're just basically going to install firmware onto the switches that tightly couple them with the orchestration tools that you're using to manage all the rest of your IT infrastructure, probably under something like OpenStack.
One of the things I really like about network virtualization overlays is you go back, if you look at what runs on a network switch today, right, you have some things that don't really change, and then you have things that change all the time. What changes all the time? Whatever has to do with that application, and that's going to change more. So it seems to me, we got that kind of duopoly of the network switch, where it's got to have a routing protocol. I'm going to tell it to join the routing protocol. I'm going to put an IP address. I'm not going to change that stuff, right? And then I have application policy that in the kind of traditional architecture of that we've traditionally done has been, we need to pull that application policy onto that switch. And it seems to me, when you take that network virtual, or that application related policy, pull it into the virtual network, it creates a really beautiful, very clean abstraction. Now you can say, I have, whether it's the same person, whether it's a different person, I have my network switch. All it does is think about, how do I connect to the rest of the world? It's not thinking about that application policy. And we're able to kind of pull that job, that duty of, the application policy into the virtual layer. What do you see as challenges or opportunities for, the monitoring community for that?
Well, that was one of the reasons why we worked with the Open vSwitch guys to implement sFlow within the vSwitch, because I saw a presentation from VMware a few years ago saying how the number of vPorts had exceeded physical ports, and I'm sure right now the numbers of vPorts completely dominate in most data centers. And so really, if you don't have visibility in the vSwitches at the software edge, you don't have visibility at all. And having the same measurement technology in the physical and the soft switches, I think, helps a lot to collapse the silos and give you that end-to-end view that you need. So with sFlow, you can enable it on all the ports, physical and virtual, and get that end-to-end view of how encapsulated traffic is flowing over the physical infrastructure. That's one of the strengths of sFlow, in fact, is that very little analysis is performed on the device itself. All it does is export randomly sampled packet headers, and it's up to the analytics software to pull those apart and make sense of them. And so if you're running VXLAN, you just see the underlay and the encapsulations and the VNI and the tenant traffic all laid out for you in the protocol stack.
Oh, very nice.
That's been captured by the physical switches. And so that allows you to very easily see how that traffic flows across the infrastructure and do troubleshooting. So if you're seeing packet loss on a link, you can go up and see, oh, well, maybe one tenant is DDoSing another tenant or something. And you can start to apply a coherent and orchestrated set of policies across both the physical and virtual layers. And divide and conquer is a really important piece here. If you think of a challenge like denial of service mitigation, these switches, for all their power, really don't have the packet filtering capacity of an ASIC. An ASIC can drop traffic, with great precision at line rate at terabits. There is no x86 core that can run a terabit of traffic. So if you program the physical switches to filter out flood attacks, then you can leave the functions running in software to mitigate the application layer attacks. So I see there's a good sort of, if you can orchestrate both, you can do a much better job than you could do at either place, because the physical fabric doesn't really understand what's going on at the application layer anymore, because there's just so many layers of abstraction, and the software edge is vulnerable to extreme traffic conditions in the hardware. And particularly if you look at fabrics, you sort of have this shared fate. If you saturate the fabric with traffic, all services that use that shared infrastructure are vulnerable to that. And so you can have these sort of cascading failures between logically separate tiers in the data center, whether it's front and back end or tenants interfering, noisy neighbors. And I think that's where there's a real opportunity to sort of integrate control of the hardware with control of the soft edge in order to do better performance isolation. And I think analytics is really the key to that. You need to detect these situations in real time and then have the orchestration tools to distribute the right control actions.
Has there been any new phenomenon that you've seen kind of popping up in traffic analysis?
Well, I think we're really sort of innovating around sFlow. You were talking about sort of predictive analytics, but I think there's very little predictive value in traffic. If you need a lot of statistical multiplexing to get a predictable time series. So if you're looking at the WAN link, yeah, you can sort of trend day to day what's going to happen and have a pretty good prediction about what's going to happen tomorrow. Mm-hmm. But within the data center in the LAN environment, you can't tell when somebody's going to run a Hadoop job or where those shuffle flows are going to go. And so really, I think the breakthrough is in real-time feedback analytics. And so that's what we've been working on is real-time sFlow analysis. So we can detect elephant flows in well under a second. And then you can use your control plane to provision paths on the fabric to avoid collisions, because ECMP actually doesn't do that great a job of load balancing large flows. They can very easily hash onto the same path, and then they're just stuck there, and you have like half the capacity that you theoretically could have had you split them. And so if you have the analytics to detect that in real time and the control plane to affect change, then you can dramatically increase throughput.
That's fascinating. You don't have to think about how to tune the hashing algorithm and things of that nature if you have a little more insight there.
Yeah, and so you can then do exact matches on those flows and just push them on a different path. Or large flow marking is an interesting one. There was an interesting white paper from Cumulus and VMware, and they're showing that if you mark your large flows as less than best effort, you dramatically improve response times in your data center without significantly impacting throughput.
I really I'm going to have Martin on the show, and I really want to ask him about that, because he told me using, at one point, I don't want to misquote him, but he had told me one time, using mice and, at least the early studies of real, just tagging on mice and elephants classification alone versus all the other, DSCP buckets and all the other traditional QoS. But just looking at mice and elephant alone can really potentially offer some just tremendous advancement in managing prioritization and performance in the data center. I looked into the paper, but it's such a fascinating leap, because the thought of trying to manage, how am I going to manage a private cloud that has a tier 1 application that's not latency sensitive, all the way up to a tier 4 application that might be latency sensitive, and manage that in a really dynamic environment. And that mice elephant flow optimization, it seemed like one that might have some potential to add.
Well, if you think about how people manage now, is it's basically sort of intelligent guesswork. I mean, most people don't, as you said, don't really know what their traffic is, and they're sort of guessing how much of each class of traffic they have, and because they're not continuously monitoring it, they just really, those previous rules of thumb may no longer apply, and you basically you're running blind until something goes horribly wrong, and then you do another sort of traffic study and try and hope correct things. Whereas I think continuous feedback and monitoring of everything is just a radical transformation in the way you orchestrate infrastructure. So you don't need to guess anymore. You just are directly measuring everything, and that to me is the real promise of cloud infrastructure. I mean, in spite of the fact that people have virtualized all their workloads, CPUs still run at very low utilizations.
Yeah.
And so there's this tremendous cost savings that are, or increased revenue for a service provider that are available if you can right size resources. And that really requires an accurate measure of actual demand. And then you can allocate the right bandwidth to that service. You can allocate the right amount of storage, the right amount of CPU, right amount of memory. And you can very rapidly flex those resources between different applications as things change by time of day, or as new services are set up or spun down. And I think that's going to be the really interesting thing, is having the whole data center really adapt dynamically to changing workloads, rather than being this rather statically provisioned, and in being statically provisioned, very over-provisioned resource.
Well, it seems like that we've always done things in a very reactive fashion, with this ideal that one day we'll be able to do things proactively, and that seems to capture a lot of what you're saying. It's this ability to go from reacting to things historically, systems of record, to move to a systems of engagement, where we're able to be proactive about how we conduct our business. Before we go, is there anything else?
A final comment. I mean, picking up on the move to bare metal switches.
Oh yes.
As a software vendor, that's really exciting for us, because I think right now people think bare metal and they're thinking that they're going to save money. And I would argue that the reason why you're going to move to bare metal is not because of the low cost, although that's a good plus. It's really that software vendors like us and many others can really deliver value on top of those software platforms. So we're working with Cumulus Linux, and it gives you a tremendous environment in which rather than being hamstrung by whatever CLI commands or APIs a vendor chooses to expose, you can just go right in there and compile your own software and install your own applications, and make that hardware do what you want and deliver tremendous value on top of these open platforms.
But it seems like to me, like one of the things I think about that is like especially we have the Internet of Things kind of representing the fact that every widget that exists, pretty much every widget that's out there, most of them are not technical or high-tech widgets, right? And they're all going to become high-tech widgets over the next few years. And as that happens, every one of those businesses that traditionally hasn't been a tech business is going to at least become a much more tech business, and there's going to be opportunities and needs. In some cases, there's going to be lots of layers of the technology stack where you can use what's there, but there's a lot of innovation happening. And one of the key things there that seems to be interesting to me is it affords you that opportunity, like you were saying, to if there's a feature that I want, if it already exists, it's commodity. right? It's not going to be a differentiated part of whatever product I'm out there. But if I really have the opportunity to build something differentiated, we need to have that flexibility on the host to be able to leverage the hardware as we see fit as consumers, right?
Yeah, and if you're in the bundled model, if your switch vendor isn't innovating in the areas where you need them to, you're sort of stuck. I mean, there's a really interesting slide that Cumulus uses in their presentations where you sort of see a top of rack switch installed, and it's buried under cables. I mean, you're not pulling that sucker out, but you could change the software on it. And so if your vendor isn't innovating and delivering the features that you need as your business changes, you can, an open hardware platform allows you to install new software or add, with something like Cumulus Linux, if it's a competitive advantage to you, you can write your own applications in-house. And I think a lot of service providers would find that very attractive because, orchestration and lower costs are their, competitive advantage. And so they can develop those easily themselves on these platforms, rather than being limited to the feature set, that sort of lowest common denominator that a hardware vendor would implement because if it doesn't pass the 80-20 rule, they won't do it.
But to me, I mean, that's the part of IT that, just to quote the old article, that's the part of IT that doesn't matter, right? It's not that it's not important, but there's components that will not differentiate. Anything that you're trying to do will not, do anything that really keeps the doors open on a business and keeps the paychecks and coming in and the lights turned on, right? We need to have the ability to do things that are differentiated, and sometimes that's developing our things ourselves, and other times it's having access to really open market of independent software vendors, which I think Cumulus is one of the companies that's really doing a great job, being really true to the Linux community rather than trying to say we're going to have just our own open ecosystem. I think really is going to make a big impact there.
Yeah, but what it's great is it gives you choice because you have sort of diametrically opposed architectures here. You can, Cumulus is addressing the sort of DevOps model and saying, okay, let's make your switch just like a server, and then you can use Puppet or Chef or whatever to orchestrate both. And it's just like a server. Whereas Big Switch is coming in from the more traditional sort of SDN with a central controller managing the switches. And the same hardware can be used for both. You could boot up Cumulus and go the DevOps route, or if your requirements change and you say, okay, maybe I'm going to take those switches and use them to do packet capture, then you could install Big Switch software there and do Big Tap.
Well,
it's really good investment protection. I mean, that hardware is yours, and you should be able to do what you want with it, and as your requirements change.
That's just a really powerful point, and I think hopefully as this market matures, that's what we'll see. A lot of things that happen that give more bargaining power and just more overall power to the consumer, because that's really what it all should be about. But on that last point, one more thing there to highlight that I think is really cool. Earlier you talked about, or you mentioned leaf spine architectures, and I think how they kind of play into that dynamic. You look at a leaf spine architecture and you start to think, well, today, what if I wanted to deploy a traditional application space? Even in that context, I still need more east to west traffic flow than I used to a few years ago, right? And even if I run a traditional network operating system, running that in a leaf spine architecture solves that east-west traffic challenge. It increases performance. It does great things for me. But what happens if I want to go Puppet or Chef? What architecture should I use then? Oh, same leaf spine architecture. Well, what happens if I want to go over to OpenFlow and run a pure OpenFlow environment? What physical architecture should I use there? Oh, it turns out same spine leaf architecture. So, well, the idea, I can just change the operating system out. That's really cool. But when you scale that out to think, I could deploy not just one box, but I could deploy 50 boxes, 50 switches in a complex architecture with leaf spine, following leaf spine principles, and I could change the software on the entire thing without changing a cable, because it's just a really powerful network architecture paradigm that way. So I think that kind of enhances that whole open networking value proposition.
Yeah, I mean, the key to that is the sort of ONI bootloader. And you sort of see that, I mean, that's the way you deploy Cumulus Linux or Big Switch, that you basically have your server that's got all the images on and the configurations, and then you just reboot your switches and they all download their new firmware, download their new configurations, and it's completely lights out. Nobody's going in and typing anything into CLIs. It just happens completely automatically at scale.
If it wasn't already apparent to you, monitoring is more important than it ever has been. We got so much new stuff going on, and so I think it's going to be an exciting year. And Peter, thank you for joining us.
Okay, it was my pleasure. It was great talking to you.